The clause 4.4, the title is Management System and Processes. The requirements are defined in details if you look into ISO 9001. But ISO 14001 and ISO 45001 define these requirements in generic. The first sentence from clause 4.4.1 from ISO 9001 is that the organization shall establish, implement, maintain, and continually improve the processes needed for the quality management system. What is the meaning of establish, implement, maintain, and continually improve? It means PDCA, that is, plan, do, check, and act. It means that the processes are required to improve gradually through the PDCA approach. Process means converting input into output, and procedure means a set of activities in a logical sequence between input to output. It is already understood in the previous presentation. Standard asks to determine processes needed for the quality management system, determine the input to the process, determine output from the process, determine sequence and interaction maybe with other processes, determine appropriate process performance indicators to decide that the process is functioning well, determine resources required to execute the process, determine responsibility and authority for the effectiveness of the process, determine risks and opportunities from the process. It will be understood through the presentation of clause 6.1. Evaluate the change and thus improve the process. Each department or function shall identify the processes relevant to the management system. The standard does not define any specific format to maintain documentation and records for these requirements. It will be understood with certain examples now. The organization can use a turtle diagram. The organization can use SIPOC diagram, that is, supplier, input, process, output, customer. The organization can use tabulated data to map the processes. In this table, the name of the function is sales and marketing, and the name of the process is inquiry handling. In the inquiry handling process, the input is customer inquiry and the output is offer to the customer. To convert input into output, that is, customer inquiry into an offer to the customer, we need manpower, we need travel arrangements, we need computers and internet and many other resources. At the same time, we need product stock status, we need the existing order status, we need product brochures, we need competitor data and freight rate, and many other supporting documents. In conclusion, a number of resources and supporting documents are required to convert input into output for the execution of the process. Standard also asks to set a process performance indicator to decide whether the process is functioning well or below expectation. In this example, the process performance indicator may be inquiry to order conversion ratio, order booking value in terms of money, number of orders booked. Sales turnover value indicator may be related to efficiency or effectiveness. Inquiry to order conversion ratio is 35% in this example. The 35 value is determined based on past data. The past duration may be 1 quarter or 6 months or 1 year in order to have appropriate base value data. The base value is not called objective. There is a very thin line difference between base value and objective. In this slide, you can see past, present, and future. My daughter has completed classes 1st to 9th in the past. My daughter is currently studying in class 10th. My daughter will study class 11th and class 12th in the future. If I look into the past scorecards, I note that my daughter can achieve 80% of marks easily and consistently. Hence, 80% of marks is set as a base value that my daughter can achieve easily. The actual score of class 10th will be compared with the base value to decide how she would do in class 10th. My daughter has an objective to get admission in the medical profession after schooling. Admission in the medical profession is not possible with 80% of marks. She has set the objective for the future to get 95% of marks in class 11th and 12th. It is set for the future. It means it is the objective. The base value is past data. The objective is for the future. This is another example of understanding process mapping. The name of the function is purchase and the name of the process is procurement. In the procurement process, the input is the purchase request and the output is the purchase order. To convert input into output, that is, purchase request to purchase order, we need manpower, we need computers, and internet, we need SAP or ERP software. At the same time, we need material specifications, we need a list of approved suppliers, we need technical and commercial approvals. In conclusion, a number of resources and supporting documents are required to convert input into output for the execution of the process. In this example, the process performance indicator may be number of days to convert PR into PO, number of events of purchase order amendment, number of days of nil production due to no raw material available. Any relevant process performance indicator may be set to decide whether the process is functioning well or below expectation. The base value can be derived from actual past data accordingly. This is another example of understanding process mapping. The name of the function is production and the name of the process is manufacturing. In the manufacturing process, the input is raw material and the output is finished goods. But raw material is physical input and finished goods is physical output. The management system requires input and output as documentary evidence. In the manufacturing process, the input is the production plan and the output is the production log recording data. To convert input into output in the manufacturing process, we need manpower, we need infrastructure facilities, we need utilities including air, water, and energy, we need raw materials, we need monitoring and measurement resources. At the same time, we need the quality control plan, we need the quality control report for raw materials, we need the procedures, we need safety guidelines with do and don't. In conclusion, a number of resources and supporting documents are required to convert input into output for the execution of the process. In this example, the process performance indicator may be number of events of first-time pass, number of events of plan versus actual production. Any relevant process indicator may be set to determine performance. The base value can be derived from actual past data accordingly. To understand specific performance or relevant performance indicators, let us see the example, I have a car. In January, I traveled 1000 kilometers. In February, I traveled 5000 kilometers. In January, the car consumed 100 liters of fuel. In February, the car consumed 500 liters of fuel. Does it means the car performance was good in January and the car performance was good in February based on the consumption of fuel? The consumption is based on the distance traveled, that is, output achieved. It is relevant or specific to kilometers. Hence, in kilometers per liter, the indicator is the same in both months. While setting environmental performance indicators, we need to consider the output as relevant or specific. These are certain examples of environmental performance indicators. Specific effluent generation in liters per unit of the product. Specific waste generation in kilogram per unit of the product. Specific steam consumption in kilogram per unit of the product. Specific electricity consumption in kilowatts per unit of the product. The safety performance indicator is also calculated similarly. For example, in Factory A, there are 4 accidents that occurred in the last year. In Factory B, there are 40 accidents that occurred in the last year. Does it mean that the Factory A has a lower number of accidents is good on the basis of safety performance, and the Factory B has a higher number of accidents is poor on the basis of on-safety performance? Both factories A and B have the same safety performance when you look into the accident frequency rate. Both factories have 3 shifts of operations. Both factories have 8 hours of working in each shift. Both factories have 365 days of working. But the number of employees at Factory A is 200 and the number of employees at Factory B is 2000. Hence, the accident frequency rate is the same as per the below formula. The accident frequency rate is an indicator of the number of accidents at how many working hours.